Welcome back to Advanced Functions for Polynomial Functions chapter. Today it's lesson number 1. In this lesson, we're going to talk about identifying and describing different characteristics of polynomial functions. First, what is a polynomial functions? So before, we did take a look at a polynomial where polynomial expression could be written like this, where the highest degree is the n, and as you move down, the coefficient and the exponent, it will decrease by 1 or it will go in descending order. And at the end, a to the 0, there is x, but it's x to the 0. So any number to an exponent of 0 is 1, so that's why you don't see any variable at the end of the expression. So a is represented as a real number called a coefficient. Now there's a special name for an. So the coefficient that is attached to the degree of the polynomial, meaning the highest exponent, we call it a leading coefficient. And then the whole thing, we call it a leading term. And lastly, just a number by itself is a constant term. Okay. Now keep in mind, in order to be a polynomial, n, the exponent, has to be a non-negative integer. Okay, so for example, we could take a look at f at x is equal to 2x3 minus 5x4 plus 1. Now, ideally, you would like to have the highest exponent start at the beginning. So you could rearrange it by saying negative 5x4 plus 2x cubic plus 1. Now, as you can see, the leading term is negative 5x4. The leading coefficient is negative 5. And the constant term is 1, the one without a variable. Let's do an example. So before we do an example, there are specific names for each polynomial with different degree. So if the exponent, the highest degree, the exponent is n is equal to 0, then it's going to be f at x is equal to a0. We call it a constant function. If n is equal to 1, so for example, f at x is equal to a1x plus a0. This is a linear function. So the highest degree, the one that we see often, is y is equal to mx plus b. The degree is 1. If the degree is 2, can you imagine what it will be? It's going to be a quadratic function. Okay. So for example, f at x is equal to a2x. Now degree is going to be 2 plus a1x1 plus a to the 0 and so forth. So it's going to be the same pattern. Now this time, if the degree is 3, we call it a cubic function. If the degree is 4, it's a quartic function. And degree of 5 is going to be a quintic function. We usually do up to degree 4 or sometimes 5, but these are the special names for each polynomials. Question 1, let's do some practice. So verify the following expression as a polynomial or non-polynomial. First things first, identify if the degree is non-negative integer. 3n 2. So the degree is 3, meaning it's going to be a cubic function. So yes, even though it's square root 2 and 2, that's fine. It's going to be, yes, it's a polynomial. Now, what about x squared plus 1 over x? In this case, if I have to rearrange this, right, into an exponent form, it's going to look like x squared plus x to the negative 1. So therefore, because it's negative integer, no, it's not a polynomial function. Now, this is in a factor form, so the degree, what you have to do if it's in a factor form, you have to add the exponent. Because if I were to do a distributive property for this one, it's going to be x squared plus 4x plus 4. And then you're going to multiply with x minus 1. And then when you multiply using a distributive property, the highest degree is going to be x to the 3. So therefore, yes, it is a polynomial function because the exponent is non-negative integer. Question 2. So we're given a function, and the question is this function a polynomial? If yes, find the degree, find the leading coefficient, and the constant term. Okay, well, let's see. Take a look at the exponent, and yes, they're all a positive integer, and the coefficients are all real number. So therefore, yes, it is a polynomial. Number 1, so what's the degree? The degree means the highest exponent in the polynomial equation. The degree must be 4 over here. Even though they're not in order, in descending, you do have to be mindful about looking at the highest exponent. The leading coefficient is always attached to the degree. So in this case, the leading term is negative x4. So the leading coefficient must be negative 1. So that is the leading coefficient. And then the constant term is a number and it's not attached to any variable. So in this case, it's going to be 3. So constant term is 3. Question 3. So consider the two polynomial functions, f at x and g at x, and do the required operations. So I put it in there as a review for combination reaction that we looked at in the previous chapters. So f at x is going to be 6x minus 3x squared plus g at x is x minus 2. What you're going to do is collect the like terms, so negative 3x2. So we have 6x plus x, so it's going to be 7x minus 2. And that is going to be your final answer. In this case, we have f at x times g at x. So what we're doing, we are going to multiply 6x minus 3x squared times x minus 2. So you'll be doing distributive property, front, outside, inside, last. So 6x squared minus 12x minus 3x cubic plus 6x squared. Now I would like to collect the like terms. And I would also like to put it in a descending order. So negative 3x cubic plus 12x squared minus 12x. And that is your simplified operation of f at x times g at x. So when talking about polynomial, it's also important to take a look at a finite differences. So nth finite differences of any polynomial function is that it's going to be a constant. Okay, now constant C is related to A and N, which is the leading coefficient, and the degree of a polynomial. And this is a formula that you have to memorize and understand. Okay. So for example, n factorial, do you see the question mark over here, is represented from the number multiplied by the descending order. So for example, if I have a 5 factorial, that means it's going to be 5 times 4 times 3 times 2 times 1. Okay. So use the following number minus the preceding number rule. So what that means is that let's just assume that this is a table. Okay, so these are the y values. So this is my given y value, and this will be the first difference, and this will be the second difference, and so on. You're going to keep going until you find a constant term. So it's always the second number minus the previous number. So C minus B, B minus A. That will give you a first difference. And then to find the second difference, so you're going to subtract again. So whatever the number, C minus B minus B minus A, that will give me a second difference in terms of a constant number. Okay. Now we will be using this formula to find the value of a leading coefficient. Okay, so let me show you an example how you can apply this knowledge. So use the finite differences to find the degree of a polynomial function. So we're given value x and y, and we are going to figure out the differences of only the y value. Now you have to keep in mind that the x value has to increase or decrease by the same constant. Okay, now once you notice that, okay, so it's increasing by 1, then we're going to go ahead by finding the first difference. So I labeled triangle means a difference, the first difference of y value. So you're going to do negative 134 minus negative 476. So that will give me 342. Again, you're going to do same thing, negative 10 minus negative 134. So that will give me 126, 124, and this will give me 26, and this is 16, 0. 14 minus 16 gives me negative 2, negative 28, negative 126, and negative 344. Now, so as you can see, are the numbers, are the first difference, are they same? No, they're not the same. So we know it's not going to be a linear. Okay, now let's take a look at the second difference. So what's going to happen is I'm going to subtract the first differences. So let's do it in a different color. So I'm going to do 124 minus 342. So once you subtract it, it's going to be negative 218. Again, subtract the first difference. So 26 minus 124 is negative 98. This is going to be negative 26, negative 2. This is going to be negative 26, negative 98. And this is going to be negative 218. Again, what do you notice? Are the differences constant? No. So we can conclude that it's not going to be a quadratic function, which is a degree of 2. So we're going to go ahead, find the third differences using the second difference. So same thing, negative 98 minus negative 218. That will give me 120. This will give me 72. Negative 2 minus negative 26 gives me 24. Negative 24. Negative 72. And lastly, negative 120. Now, are the third differences the same? No, they're not the same. It's not constant. So we're going to keep going. Let's go on to the fourth difference. Now 72 minus 120. That will give me negative 48. 24 minus 72, negative 48. And if you could keep going, you will notice you get the same differences. So once you know that it's exactly the same difference, we can conclude that it's going to be a quartic function. So the degree of this given table of value is going to be a quartic function. And just an extra information, if we want to find the leading coefficient, so what we can do is you can use the formula C is equal to n factorial an. So we're going to isolate for the leading coefficient. So an is equal to C over n factorial. Now we know what C is going to be, the difference, the constant. It's negative 48 and n factorial, meaning 4 factorial. 4 factorial means it's going to be 4 times 3 times 2 times 1. So when you do that, it's going to give you negative 2. So the leading coefficient is going to be negative 2 for this table of value.